Hello and welcome to another video in this series as we learn Prolog together. In the last video we introduced this new theme around something called the cut, which can seem a little mysterious and you'll often hear words of caution around using it. So we're going to take it slowly in this section, where in the last video, this one and the next few, we'll just take small steps exploring what the cut is, how to use it, what the caution is, and how to use it safely. In the last video we provided a very minimal example just to observe the behaviour of the cut, and we saw that it stops backtracking, but it doesn't make Prolog blind to facts that are written after the cut, and they can be queried directly. So if you need a refresher, do go back. We left an open question around what kind of backtracking after the cut is affected by the cut. So that's what we're going to explore in this video today. So the example code again is very simple. We've got some simple facts that are about the property homemade and some more facts about the property ripe. The code is all online, you can find it on GitHub, and the links are on the blog and also on the YouTube site as well. So you can see here we're saying that pizza is homemade, soup is homemade, fish is homemade, and we're saying that apple is ripe, orange is ripe, and banana is ripe. And then we've created a relation about a property, a meal, and we're saying that a meal has a main, has two parts, main and fruit. These are variables because they have a capital letter, and a meal is true if the main part, the main dish, is homemade and the fruit is ripe. So a meal has a tasty homemade dish and ripe fruit. We've introduced the cut right in the middle to see the effect that it has. So just to warm up, we're going to ask homemade, just to check everything's working, pizza, and yep, pizza's homemade, and we're going to ask if the banana is ripe, because we don't want to eat a green banana. Yep, banana is ripe. And now if we ask what are the possible valid meals which have two parts, a main dish and a dessert, a fruit dish perhaps. What are they? And this is called a most general query, where every parameter is a variable. It's not filled in. Now I could have written x comma y, perfectly fine, as long as they're capital letters. Prolog knows that they are variables, but just to make it the results that it produces easier to read, I'm going to write main and fruit, and the capital M and capital F are what tell Prolog that these are variables. If I wanted just to be a little bit more concise, I could do M and F, but sometimes it helps to think about the readability of your code. So this is the most general query, it's called that, because there's everything in it. Anything is a variable. So if we run this, what do we expect? Well, we expect all the combinations that make a valid meal. We expect pizza and apple, pizza and orange, pizza and banana. Same with soup, or that's a combination, soup and apple, soup and orange, soup and banana. Or fish and apple, fish and orange, fish and banana. Those are the potential, expected combinations. But let's see what the effect of this has. Actually, let's run it without that. That's probably an easier thing to do. There's no cut, so we expect all how many are there going to be? 9. So 3 for this, 3 for this, 3 for this, 9 combinations. Let's run that. And let's let the thing catch up with us. And I'll just scroll up and down there. So, yep, we see that. We've got pizza and apple, pizza and orange, pizza and banana. And then soup and apple, soup and orange, soup and banana. And then we've got fish and apple, fish and orange, fish and banana. Those are all the 9 combinations. So that's what we expected when we don't use a cut. So there's nothing new there. Now if we introduce the cut, what happens? Let me just clear that so we can see clearly. Well, actually, before we dive in, we should kind of exercise our brains a little bit and see, well, what do we expect? We said last time that the cut stops backtracking. What this example will do is can make clear where it stops backtracking. So will it find the first one, pizza? That's satisfied. Remember, the queries go left to right. So pizza will satisfy this bit. It'll reach the cut, and then it'll find apple as the first one. And then will it stop because it's not allowed to do any backtracking? Is that what we'll find? It's a good theory. There's a lot of sense behind it. Let's see. And let's run them all through. Oh, okay, it's found 6. So let's look at what 6 it found. Unexpectedly, totally expectedly, pizza and apple are the first combination. That was totally expected because they're the first things that satisfy the query. Okay. And then it did do some backtracking because there's more than one answer now. There's 2 more. The next one is still pizza and orange. So it's sticking with pizza but finding orange as a replacement as an alternative to apple. Let's look at the last one. Again, pizza and banana. So what does that tell us? It tells us that backtracking here has happened. Backtracking back across the cut to find alternatives for homemade soup and fish was not allowed. Let's draw a picture. Right, so let's talk through what happened there. So we asked the question, meal, main, fruit, these are variables. What satisfies that? And to answer this, Prolog makes use of this rule because it's irrelevant because it's the same property. In order to satisfy this head, it has to satisfy the body. So that's the standard approach that we've talked about many times. So to do that, Prolog will go from left to right along the body of the rule and try to satisfy each goal. So the first one is homemade, and that matches this set of facts. The property is the same, and the first one it finds is pizza. So m equals pizza is a candidate solution. It's only candidate because we haven't satisfied the rest of the goal yet. So the next goal is this cut. Now the cut always succeeds, it doesn't fail, so that's fine. It'll go from there to the next one. And the third part of the goal is ripe fruit. So what satisfies that? And Prolog will then look at this set of facts because they have the same, they're relevant because of the same property, ripe. So apple is the first one. So F fruit equals apple. So that's the first solution. What we're doing here is what we have learnt much earlier in the course about how Prolog finds solutions when the query contains variables. If you need a refresher, do go back to that video that introduces variables. Now, typically now, what Prolog will do is backtrack, and it will say, okay, we've done that, now let's go back and find other possible solutions. And remember, it does chronological backtracking, if you remember, which means it works it undoes the most recent thing that was set. So ripe fruit was most recently set. So it will say apple's done. Can I find another option for a ripe thing? Orange. So M equals pizza and F equals orange is the next solution, and then it'll backtrack again and find banana. So M equals pizza, F equals banana. 3 solutions so far, and when it's done all these, it'll say, right, okay, we've kind of done that now, let's backtrack further up the chain. And it would normally go back to M, which was set to pizza, and undo that and go to the next option, which is soup, run all these combinations, and then again to fish and run all these combinations. And that's how it would have had 9 solutions. But the cut prevents backtracking across it from the right to the left, back over it. So that's now a more precise explanation of what the cut does. Previously we kind of said in a very high level way it prevents backtracking. Now we can say more precisely that it allows backtracking that happens to the right of it, but it prevents backtracking that cuts across it. So let's choose a different color here just to emphasize that. Backtracking here is fine. Backtracking here is stopped. And that's why we only get 3 answers, all based on pizza. Pizza and apple, pizza and orange, pizza and banana. It forces Prolog to commit to whatever candidate solutions have been found up to that point. So let's look at our code again. And we can see, yep, pizza, 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 apple, orange, banana. So I hope this example has helped answer the question we left open last time, which is, yes, Prolog in general, in a general sense, stops backtracking, but what kind of backtracking? And what we've said here is that backtracking that happens entirely after the cut is fine. It's when the backtracking moves across from the right to the left of the cut, that is what is stopped. Let's we could stop there, and that's totally fine. We've covered what we wanted to, but you might find that on the blog there's another picture, slightly more complicated, that's drawn the kind of search tree for that query. So homemade main, ripe fruit, and the first goal is homemade main, and we find homemade pizza, x equals pizza, as a candidate solution. And then after that is the cut. So we go down to the next goal, ripe fruit, and we find all 3, and the backtracking happens around ripe fruit. But when Prolog attempts to go back to undo the main meal, X here for pizza, that's stopped. that's not allowed. So that's why it sticks to pizza and doesn't include the combinations with soup and fish in the solution. So you can have a look at that if you're kind of interested, just to kind of look at the same explanation but from a different kind of perspective. Brilliant. So I hope you found that useful. We're trying to take this deliberately slowly. So in the last video we just introduced observing the behaviour of the cut, and we got the notion that it stops backtracking. In this video we just wanted to expose and make clear which backtracking is stopped in a rule, and it's only the backtracking that cuts across the cut, not anything that happens entirely to the right of it. Fantastic. See you next time. Bye.